So jumping into our Jupyter notebook, we are getting our news data from news API. We're just importing some libraries, and we are looking into all the news articles mentioning NVIDIA from 5th of May up until 30th. We're fetching all the articles, and we're using the text blob library in Python to calculate the sentiment polarity and give it a score from a -1 to +1, and -1 being the lowest, +1 being the highest. As you can see, we're getting the news articles with the polarity scores, and we're doing something similar with stocks. We're using the Polygon API to get stocks data. We're looking into NVIDIA stocks within the same date range. We are defining a movement classifier, wherein if the closing price is higher than the opening price, we give it a 1, and if the closing price is same or less than the opening price, we give it a score of 0. So 1 indicates up, 0 indicates down. We're just doing some simple visualizations. The distribution of polarity, sentiment polarity, is pretty normal. And this is the line graph showing the opening and closing price of stocks on different days. This is what we want to get the aggregated polarity, the mean polarity by day. So the mean polarity score for the news articles on 5th, 6th, 7th, and so on and so forth. And then we merge it. We want to merge it with our stocks data set. So the whole idea is to try to find some correlation between sentiment polarity and the movement of stocks. So we have, we can see I've already set up Kafka and Zookeeper. They're running in the background. We have the producer Python file of news and stocks. We have this is the filter and upload PY. So this is what we are going to use, all the CSV files that we get from our Spark stream up to the HDFS or distributed file system. And from there, we will use the sentiment stocks workflow. This is a Hive query language file, HQL file that we are going to use to take all the CSV file from our HDFS, load it into our Hive database, create tables, load the CSV files into the Hive tables, perform the aggregation and join operation that we saw in the Jupyter notebook, and then take the final output table that we will have in Hive and then send it to a Google bucket. So this is going to be the architecture. We're going to use 2 producers, Kafka producers for the news API and the stocks API. Zookeeper is our scheduler. We have 3 streams running in Spark. Stream 1 is going to take news API, whatever it is, it's going to write it to our local file sync. Aggregated output is going to aggregate the sentiment polarity by date. Stocks API is for the stocks data. This is all going to write it in our local file sync. We're going to send it to Hive, perform our operations. From there, we send it to Google Cloud, and from Google Cloud to BigQuery, and from BigQuery, we will import it in PowerBI to create visualizations. This is the full architecture. Now, jumping to the Python file. So here, just some import statements, initializing the API, producer, defining our parameter, getting the news articles, running the polarity sentiment analysis, and then sending everything to this to a topic called news topic. And same for stocks. So same thing, we're looking into NVIDIA date range, the movement class classifier, and then sending it to my stocks data. This is the topic for our stocks. So stream 3 is going to listen to this topic, and then streams 1 and 2 are going to listen to the previous topic. Okay, so now we will just run. I'm just going to run the producers. At the same time, we are going to start Spark in our 2 VMs. So what we are doing here in Hive, this is for the news API, the streams 1 and 2. So this is just some import statements. We're defining schema for our Spark stream, and we're reading from Kafka. We're subscribing to news topic. As you remember from a producer file, this is for news API. We're passing the JSON messages, ensuring that it has proper timestamps, and then we pass it on to string one, the full output. It's going to write it to the full output directory in our local sync, and stream two is going to perform the aggregation average polarity by date, send it as average sentiment, and then write the output CSV file into aggregated output. The checkpoints are just for storing checkpoint of the Spark streams. So we will run this first. We go to paste mode. Now, at the same time, let's look at stocks. So just some import statements, the schema, defining the schema, reading from Kafka. We're subscribing to my stocks data topic from our stocks producer Python file. We're passing the JSON message, and then we're writing the output in stocks output directory. So we take all of this, and then exit. We can run the producer a few more times. And the stream does like give you outputs of blank CSV files at times. So now we can see that the full output, aggregated output, and stocks output directories have been created. They weren't there before. The Spark stream has created and given us some sort of output within these directories. I'll show it to you in a while. Just run this first. And okay, producer. Let's go here. And as this is running, we can go to stocks output directory, see what files are there, head, port. See, yeah, sometimes Spark gives us blank outputs. This one has all the values. Similarly, we look at full outputs. It just has the one CSV file. And if we look at, okay, yeah. So now we have two new outputs within the same directory. We can now, yeah, okay, this one has some values. Okay. Yeah, so this is what I was talking about. Sometimes it just gives you blank files. And now we will look at the filter and upload file. So, okay, the stream is writing outputs as we're working on these. What this does is it takes the local directories, aggregated output, stock output, full output, and then maps them onto directories in our HDFS distributed file, Hadoop distributed file system. So within our HDFS, we have target directories, big data streaming, sentiment directory. And as we saw, some CSV files were empty. So anything, only files that have more than one rows are going to be uploaded there. If not, that means it's a blank file, so it's just going to be ignored, skipped. Yeah, this is all just, this is to upload the file, and we're just calling both the functions here. Now let's just look at, okay. So we can see in aggregated output, these two files have been skipped because they were empty files. Any files, any CSV files with value are going to get uploaded. And once that is done, we are going to look at this workflow HQL file. HQL is Hive query language. What we're doing here is we're creating a database stocks. Using the stocks database, we create table sentiment, and in sentiment, we are defining the schema. So date and average sentiment. Now this is passed as string because this is in timestamp format. We load the data from the big data sentiment directory. I think we saw it. Yeah, we saw it in the Python file we used to upload to our HDFS. From there, we create table sentiment where we cast a substring from first to the 10th character as date. So in this string, we have it in timestamp format. We are just extracting a substring from within the timestamp to get the dates. And then we're creating another stocks table, defining the schema, fields, loading all the data from the stocks directory into our table. And then the same thing here, casting the substring as date from the first to the 10th character. And now we're performing the join operation here. We're getting all of this movement class and average sentiment with stock symbol, date, and the stocks open, close, high, low values. And we're joining on date. From there, we've already created this bucket in our Google Cloud Storage. Keep in mind that all the storage storage account names, bucket names have to be unique globally, not just within your account. So we are inserting everything from this table into our bucket. From there, we'll send it to BigQuery, and from BigQuery, we get it to Power BI and perform visualizations. So, and in order to run the Hive file, yeah, so this is the bash command that you use to create buckets. I've already run it. It's already there. So now we run our HQL file. Yeah, so it's while it's running, I'll show you what I meant by timestamp. So this is the format the date column is in. And we're taking the characters from first up until 10th. And this gives us a column that we can keep in date format, which helps to merge the two tables. Okay, so our table is created according to the workflow that I just defined. Now, the preview, okay. Yeah, so the preview SQL file just uses the stock and selects the 10 rows from the sentiment stocks table, the table that we just created. This is just to check whether our table has any values or not. Okay. So yeah, these are the values that we have there. Now we go into our console. We go into storage buckets. As you can see, I have created this bucket here. And within that, we have this directory sentiment storage. And now we have this file. What we are going to do is jump into Power BI. Get data from other sources, and it's going to get data from another source. Google BigQuery, you connect it. And if you've not already logged in, it's going to prompt you to log in using your Google ID. And once you log in, it should show you all the projects that you have. Okay. Then you go into BigQuery. And we create a table. And we create the data set. We create the table from Google Cloud Storage. And then we have this sentiment stocks. We select the data set and we give the table a name. So stock sentiment. Now we can define source file has defined a schema for us. In this case, okay, yeah, it had to be a CSV file. Now we can define the schema. And to define the schema, we can just look at the HQL file where we created the table in the first place. So we have date, sentiment, symbol, open, close, high, low, and the movement class. So what we can say here is we have the date as type date. You have the symbol type string. We have sentiment. Sentiment. Sentiment is a float. Symbol is a string. Open, close, high, low. Open, low, and movement. Movement can be an integer because it's a 0 or a 1. This is a float. This is a float. These are all float. So we create the table. Okay. So we have the stock sentiment. Now we refresh this. The table is there. So we load it to our. So direct query is when you want to create live dashboards, or you can just import it. So you run those locally. Okay. So now we have all of our variables there. So we'll start creating x-axis. Obviously, we want dates. We just want, since it is all within the same month, we'll just look at we want average. Average of this is, well, oh no. High, low, but low. Average, open and close. We'll create another line graph. Same with date, but on the y-axis this time we're going to use sentiment. So, okay. No, just yeah. So on this 22nd, the closing price was higher than that of opening price. We look at this on 8th of May, the day with a pretty low polarity score, the closing price was lower than the opening price. So yeah, same way, we can use this to drill down on specific days. Obviously, we could do it with queries, but Power BI is a visualization tool, and doing all these things visually is much easier.